Hello, PLP geometry. So welcome to video 1B, still covering the rigid motions. So I'm going to give you an example of each type of problem you have to do on this upcoming assignment to help you out. So this first one is find a line of reflection experimentally. So it says determine the line of reflection that would map the pink figure onto the dotted outline of the image under the reflection. And it says click and drag the yellow dots to change the line, click and drag the line itself to move it in parallel. So the two objects that matter right now are the pink and the dotted. So watch what I do when I move this line. I'm going to move that blue out of the way. So I'm actually going to screen grab this. We're going to take a look at the pink and dotted just to kind of get an understanding of what we need to do here. So I need to draw the line of reflection in between these two figures so that the pink would reflect onto the dotted. So remember, when you're talking about this, the key phrase is the perpendicular bisector, right? Your reflection line is the perpendicular bisector of the segment connecting the pre-image with the image. So if I look at this point right here called A, it's going to correspond with this point down here, A prime. If I connect them like so, my line of reflection has to be the perpendicular bisector of this segment. So again, if you can see it going like this, I think what I'm going to do is I'm going to draw my line somewhere right around here. So I need to somehow move this line to make it look right there. And what's going to happen nicely is that this blue figure is going to go on top of that dotted one. So let's take a look at this. Okay, so I'm back on here on Delta Math. So again, I'm going to grab this, and I know that my line has to kind of turn, so I'm going to grab one of the yellow dots and kind of twist it and turn it. And I'll grab the yellow dot down here and twist it and turn it. And now it's just finagling, right? And again, it might be difficult. Let me go up there maybe. No, oh, close. Again, I'm going to, oh, man. Okay, there. And now I know I just have to move my line parallel. Perfect, right? And it's even going to tell you, you are correct. You may now press submit. So again, what I would do is, again, try to visualize connecting two of the corresponding vertices and then get that perpendicular bisector going down through the segment. All right, the next type of problem is going to be to translate the figure by a vector. So we need to translate the figure 2 units to the right and 2 units up. So notice it says draw a vector from the origin 2 units to the right and 2 units up. So see this yellow dot here, this is the origin. I'm going to click and drag this yellow dot 2 units to the right and 2 units up. So click and drag 2 right and 2 up. Okay, that is my vector. That represents the distance and direction that each of my vertices has to slide. So now it says move the tail of the vector to each vertex. So the tail is the dot, right? The starting point. So I'm going to move it to here. I'm going to use my mouse. Okay, I'm going to move it to the next point. Okay, and the third point. Okay, and now notice what it does is it moves my triangle for me, and notice that the pre-image, the pink, and the image, the blue, are the same shape, same size, just moved, slid in the coordinate plane, and you're done. Okay, the next one is a rotate figure about the origin. So it says follow the guided instructions below to rotate the figure 270 degrees counterclockwise about the origin. Be aware that you will do multiples of 90 degrees. So 90 degrees, 180, 270. Okay, so just be aware of that. And again, I'll show you what that means as we go further. Okay, so what they're going to do, and let me change this problem type to 3 points. Okay, so what we're going to do here is we're going to take this triangle and rotate it 270. Now it says clockwise this time. So again, sorry to confuse. Let me pause and get a counterclockwise. Okay, so again, I got a 270 counterclockwise. It is a 3-point triangle. So notice it says draw a circle centered at the center of rotation, which is going to be the origin, such that one of the vertices of the figure is on the circle. So I would just go to the closest vertex of the triangle. So I'm going to click on this yellow. I'm going to drag to the closest vertex. No need going across the triangle. Just okay. Very good. So now it says click and drag to draw a line through the yellow center and the vertex of the circle. So we're going to click and drag a line connecting the yellow center to that point on the triangle I just did. And there I go. Good. So now we need to now draw a line through the yellow center that is perpendicular to the line that you just drew. So you did some lines of reflection. So again, perpendicular, if this one goes this way, following my cursor, then my other line is going to go this way. So let's try our best here. Okay, and it won't let you go unless you get it right. And again, it should create like this X-looking thing, right? Right angles. So now it says rotate the figure 270 degrees counterclockwise using the red dot. So counterclockwise is going to be this way. Now, what I want you to visualize is every time you hit where the line intersects the circle, that is 90 degrees. So we are doing 270. So if I go here, that's 90 degrees. This is 180, and this is 270. And that would be where the final figure goes. Okay. Now down here, they want you to state the coordinates of the new image, right? So we take a look at the pink. So -5, -6, testing your coordinates. So -5, -6 was this point right here. All right. Well, this point right here is now over here. And this is the point -6, 5. So this point is at -6, 5. Okay, the point -3, 3, which was here, is now the point on the circle on the other side right here, which is at -3, 3. So it was at -3, -3. Now it's at -3, 3. And the final point, -8, -2, which was this point here. When we rotate it around to 270, it becomes this point here, which is at -2, +8. -2, +8. It says try values. Hey, we're correct, and we can move on. The last problem you're going to see here is a mapping without coordinate plane, level 1. So it says triangle ABC and triangle EBF are drawn below. Use the drop-down box below to determine a transformation that maps ABC onto EBF. So you have three options, right? To get ABC onto EBF, should we use a flip, which is a reflection, a slide, which is a translation, or a turn, which is rotation? I hope you can see that we need to turn this triangle ABC to fit it onto triangle EBF. And it looks like point B, notice it's used both times. Point B is going to be that rotational point, that center of rotation. So I believe it's going to be a rotation. Okay, so it says counterclockwise about a point. So again, I think B is going to be my point. And now what they're saying is until some segment has the same slope as some segment. This is just correspondence, right? If you look at, say, let's go AC. If you look at AC, when I rotate AC around, AC has to line up with EF. So we need to make sure that the slope of AC will be the same as the slope of EF. And again, it's just because they are corresponding. I could have picked BC and BF. I could have picked BA and BE, right? Corresponding sides. And if I make it go, and we're on top. And that's all they want you to do, is just match the pre-image with the image again. I'm going to do one more of these, maybe with a reflection. Okay, last problem here. So now we want triangle XYZ and triangle X. We have triangle XYZ and triangle XYR drawn below. It says use the drop-down boxes below to determine a transformation that maps triangle XYZ onto XYR. So I hope you can see that if we take triangle XYZ and just flip it so that Z comes over here where R is, we're going to be in business. And that means we need to flip Z about line or segment XY. So this is a reflection. We're going to go over line XY. When I do that, notice they line up, and we are good to go. All right, so best of luck on this assignment. There's going to be two options. There's going to be a regular number 1 and then a number 1 extension. So if you feel confident, try the extension. All right, thanks for watching.